Problem number 12. In an air standard diesel cycle, the compression ratio is 16 and at the beginning of isentropic compression, the temperature is 15 degrees Celsius and pressure is 0.1 megapascal. Heat is added until the temperature at the end of the constant pressure process is 1480 degrees Celsius. Calculate the cutoff ratio, the heat supplied per kilogram of air, the cycle efficiency. It is given that the compression ratio R is equal to V1 by V2, which is equal to 16. T1 is equal to 273 plus 15, which is equal to 288 Kelvin. P1 is equal to 0.1 megapascal, which is equal to 100 kilopascal. T3 is equal to 1480 plus 273, which is equal to 1753 Kelvin. We know that P2 is equal to P3 due to constant pressure heat addition. V4 is equal to V1 due to constant volume heat rejection. The cutoff ratio RC is equal to V3 by V2. For isentropic compression 1 to 2, T1 V1 raised to gamma minus 1 is equal to T2 V2 raised to gamma minus 1. So T2 by T1 is equal to V1 by V2 raised to gamma minus 1, that is R raised to gamma minus 1. So 16 raised to 1.4 minus 1. T2 is equal to T1 into R raised to gamma minus 1, that is 288 into 16 raised to 1.4 minus 1, which is equal to 873.05 Kelvin. For constant pressure heat addition 2 to 3, P2 V2 by T2 is equal to P3 V3 by T3. RC is equal to V3 by V2, which is equal to T3 by T2. That is T3 by T2 is equal to 1753 divided by 873.05, which is equal to 2.01. So RC is equal to 2.01. For isentropic expansion 3 to 4, T3 by T4 is equal to V1 by V3 raised to gamma minus 1. T3 by T4 is equal to V1 by V2 into V2 by V3 whole raised to gamma minus 1. T3 by T4 is equal to R by RC raised to gamma minus 1, which is equal to 16 by 2.01 raised to 0.4, which is equal to 2.293. T4 is equal to T3 by 2.293, that is 1753 by 2.293 is equal to 764.5 Kelvin. Heat supplied QH is equal to Cp into T3 minus T2, which is equal to 1.005 kilojoule per kilogram Kelvin into 1753 minus 873.05, which is equal to 884.35 kilojoule. Heat rejected QL is equal to Cv into T4 minus T1, which is equal to 0.71 into 764.5 minus 288, which is equal to 338.32. The thermal efficiency is equal to 1 minus QL by QH, which is equal to 1 minus 338.32 by 884.35, which is equal to 0.61, that is 61%. Or we can use the standard formula for efficiency of diesel cycle. Thermal efficiency is equal to 1 minus 1 by gamma into RC raised to gamma minus 1 by R raised to gamma minus 1 into RC minus 1. That is 1 minus 1 by 1.4 into 2.01 raised to 1.4 minus 1 by 16 raised to 1.4 minus 1 into 2.01 minus 1, which is equal to 0.613, that is 61%.